now we are going to start with the new topic, that is the functional group, right? Functional group is actually something which is very important. Actually, when they are attached to the carbon chain, they just determine the properties of that compound, right? So that means, what does the functional group indicates? So they are you can say a atom or a group of atoms that just determine the properties of the compound. That just determine the properties of the compound, right? So we are just going to look at what kind of functional groups. There are many functional groups, but out of them we are just listing the few important functional groups which you will you'll encounter in this chapter, and you have to use them in a certain properties. They are actually very important functional groups, right? So what are those? So they are alcohol. So how you come to know that the given functional group is an alcohol, right? So just look at here that if you have got a chain and at the end or in between you get to see this hydroxide group, that is the hydroxyl group. What you call this group as? Alcoholic or hydroxyl group, right? So if you see this hydroxyl group attached in a carbon chain, that means it indicates the functional group is present, and that functional group is the alcoholic group, right? So that means in case of alcohol, which functional group is present? If OH is present, what is OH? It is a hydroxyl group, right? So if it is present, that means the functional group which is present in a chain is in the alcoholic group, that is the alcohol, right? So that means if we have a functional group, that means we have to have a special ending for the name, right? So these functional groups they serve as a secondary suffix, right? So in this case, what will be the suffix which will be used, and the secondary suffix, because primary suffix indicates the ane, that is the type of bond, but the secondary suffix indicates the type of the functional group which is present in the chain, right? So if there is OH group present, that means the suffix which you are going to use will be all, right? This indicates this all is taken by this all, right? So it is if it is alcohol, then it is the suffix is all, like methanol. So if I say you that I have a carbon compound named methanol, so its name ends with all. So that means just listening to the name of the compound, it should be clear that it is an alcohol, right? So this is the first functional group, the important one. The second one is the aldehyde. So how do you get the information that yes, the functional group is aldehyde? So obviously we have to look for the certain kind of group which is present. It can be group, it can be group of atoms, as I told you. So what indicates that it is an aldehydic group? That is the CHO, right? So if there is CHO present in the chain, that means it is an aldehydic group, right? But not always you are going to see the CHO written in the same form. So you need to have the structure in which you get to know that what kind of bond the C is forming with H and O. That indicates that how many number of valencies are actually stabilized, right? So here I have an open structure for aldehyde, that is CHO, right? And here it is ready to link with some chain, some carbon atom of a chain. So that means it is an aldehydic group, right? And the suffix we'll be using it for, it will be al, aldehyde. So that means al. Methanol, propanol, butanol, so all ends with al. So that means it indicates the secondary suffix is al, that means it is a aldehydic group, right? Similarly, we have the carboxylic acid functional group. So the formula which is responsible for it is COOH, right? So either you get to see COOH attached to a chain like this, like I'll show you an example. Suppose you get to see the COH present here. So then also it indicates that yes, it is the carboxylic acid, or you get to know the open chain structure as well, which is indicated by this. So this here, it is ready to see 3 valencies are already stabilized. It is just needing 1 valency is unstabilized, that is why it is linking to some carbon atom of the chain. And how now the question arises, how now you are going to end this name, the carboxylic acid name? It is definitely with the suffix, that is the oic acid. So oic acid is a suffix for the carboxylic acid. Carboxylic acid, that means the oic acid. Like methanoic acid, ethanoic acid, butanoic acid, propanoic acid. You don't get confused. I'll be just explaining you afterward that how you get to make these compounds and how to. It is so simple to remember these names as well, right? So it is not a big deal. So just at this moment, concentrate on these groups that you should be familiar. That if I say it is an alcohol group, so definitely it should strike your mind that yes, the chain has the OH group. If I say the carboxylic acid group, so it should strike you that yes, ma'am is talking about the carboxylic acid, that is COOH group, right? So this is what the three important functional groups, but they are not limited to the three. We have many more, right? So let us take an example of another functional group, that is ketone. How ketone is indicated in a chain? If we get to see this kind of group present in a chain, and here is a, you can say the carbon atom of the chains are present, that means it indicates it is a ketonic group. And how its name is going to end with the suffix "un." It's by the suffix "un", right? Like propanone, butanone, we have pentanone. So everything is ending with "one", that means the secondary suffix is "one", that is, it is a ketone, right? And moreover, we have one more, that is ester. How ester is indicated? If you get to see this kind of group present in a compound, that means it indicates it is an ester. And you know that esters are the compounds with the fruity smell. They are actually used in perfumes, ice creams and all. They just they are used as a flavoring agent. They have the fruity smell. It is a characteristic property of the esters, right? So how they are indicated? They are indicated by COO, right? And the bond formed is again 1, 2 and 3. That means it is left with the one valency. Again, so it has to be linked, it has a special property that it has to be linked between the carbon atoms, right? This I will be telling you after just summing up. So I think it is clear. We have few more functional groups like ether. So what is ether? It is O group, right? It is ready to link with some other atoms, right? So it is a ether. So similarly, we have these important functional groups. I think again I am repeating a topic for you. Functional groups are actually a atom or a group of atoms which just determine, if they are present in a chain, they just determine the properties of the compound, right? I think it's clear now. So we have alcohol. It is just shown by the OH group and the suffix is -ol, right? We have the aldehyde group indicated by CHO. If we talk about the open structure, it is like that, and the suffix we use is -ul, right? Carboxylic acid is COOH, that is C double bond O and this OH. It's this thing written by the suffix this thing oic acid. Again we have ketone, that is CO and the suffix is -un, right? We have ester, that is COO and the suffix we used, sorry I forgot to tell you the suffix, it is O8. It is O8, right? And in case of ether, it is ROR, that is the O which is attached. But for your class, or you can say up to your level, you should be concerned with only these, because these serves an important, you can say the functional group. So you may come across the compounds which have these kinds of functional groups, right? So this you have to just learn the chart, that you should be familiar that what is the functional group and what is the suffix which is used. Because if you are familiar with this chart, then only you can make the members from them, that is the members of the alcohol family, members of the aldehyde family, members of the carboxylic acid family, members of the ketone and ester and like that, right? So now I'm just going to tell you the method how to just remember them. Actually they are somehow similar with each other. See, aldehyde and carboxylic acid is somehow similar, the only difference lies is the O. Right, here there is no O and in this case there is an O. So that means there is a similarity between the aldehyde and the carboxylic acid. So they just differ in this O atom, right? And similarly, this ketone and ester are somehow similar to each other. You can see that it is CO and they possess one more O. So you may write CO, and if it is COO, it indicates the ester, and if it is CO, it indicates the ketone. So it is hardly a matter of one O, but it's not a small thing. It just govern the properties of the compound. So this O again, if like the CO, the compound with this functional group CO serves. They have a few different properties, and the compound with one O extra is I told you that it's an important compound compound, it has a fruity smell, that means it is again a different one. So this is how you are going to remember this chart. Then in the next, now we will be taking up that how to make the compounds out of them, right.